We made it to the weekend, you guys, and now we get to sit down and have some fun messing with our embedding model in Pytorch. This is the part I'm really excited about. I'm really excited. Is that gonna work? Yeah, I figured. So we were talking about byte pair encoding. That's what this was. We were talking about BPE, byte pair encoding, which allows you to split up words into common clusters of groups of things. So I think we also need to adjust our learning scenario because currently we haven't trained any of our AI on padding. And so I think I should do a random up to the context window size, right? Does that make sense, you guys? Context, something that we have to do here. Where are we? Data iterator. We need to figure this out. This right here. All right, we need to go to do change the context size, variable context size. Because if we do that, that's going to allow us to train for padding. Because the AI doesn't know what that is right now. It doesn't know what the padding is. Although I don't know if it matters or not because we're doing a concatenated embedding, so it should be fine. Although what we should also ensure that we're doing is when we're getting the embedding on the output, we're getting the concatenation. And we're not doing any padding, only during training. Guys, let's do some software engineering now. Let's make it happen. I want to do cosine similarity first. That's the one thing. All right, I want to do things in this order. I want to test similarity on the vectors. Thank you for the hearts, you guys. Thank you for spamming the hearts. I want to graph it. And then we'll visualize it. Maybe we'll do that at the end. And we might not do this. Like this is at the bottom of the list. Because we can do that easy. It's just I don't think we would have to replace our negative log likelihood loss. And I don't want to do that. I don't want to do that. I want to save and load the model. How do we do that again? Let's see here. I want to do, model.save. And then model.something. We need to figure out how to do that real quick. I don't do that often. So Gemini will say how to save torch model to file. Let's get this here. See, say torch.save model state dictionary. Okay, perfect. Let's do that real quick. Torch.save model state dictionary model weights.pth. Perfect. Let's do that. And then how do we load it? See, load state dictionary. Model equals my class. Load state dictionary. That's easy. Set it to eval. We're not going to set it to eval mode. Okay. So I want to compare these guys. Let me pull this up here. I want to see what it looks like here at the bottom. All right. So we subtracted the two. They're all zeros, surprisingly. So it's really weird. So it seems like, oh, okay, I know why. Because we padded it. So the only thing that it can compare to is this. And so this will give us the difference. So this is going to tell. So what I need to do is I need to mean it or something. So I need to, what we can do is we need to subtract. How do we, so we've got a nice matrix here. I'd like to do a full cosine similarity. So what I want to do, how do I do this? So I can subtract them and then come up with a mean. I suppose we could just say dot mean, right? What is that going to work? Let's find out. There we go, right there. Okay, so they got 0. Let's see what it looks like when we do two S's. So S1 minus S1. So it should be 0, which means they are exactly alike. So I think we need to do something different. See here, let's see here. Oh, the one before this one. Oh, it was? Okay, the one before that one. Got it. I don't know what song that was. That was The Awakening. It was called The Awakening. Hey, Torva! You welcome on in. Good to see you. Discord's having some issues, Torva. Let's do cosine similarity in Pytorch. All right. Cosine similarity Pytorch. Cosine similarity Pytorch. There's got to be a built-in function for that, right? There's like a nice built-in function. Right there. It's right there. Okay. Input 1, input 2, dimensions. Oh, perfect. Perfect. See, I don't have to do anything. Just use the framework. Isn't that great? Okay. So we're going to do this here. Paste that in. Oops. Cosine similarity. It was like torch.nn.functional.cosine similarity. And then we say a comma, increment, and we say comma dim equals 1. Because it's a matrix, right? It's a matrix. So let's try that. So this is cosine similarity. Boom, boom. There we go. Perfect, perfect. Do your cosine similarity, which does exactly what I want. Right there. All right, so if we do a 1 and a... Let's do a different word. Let's type the word spam. Let's see what that does. Spam. And we trained it on... Let's do the word found. Let's do the word found. So let's compare those two words. These two words should be far apart. So they should be... Whoops. Where did I do that? I made a mistake. That was real easy. I like those easy ones. I really do. There we go. Okay. So let me continue with our embedding model here for a second, and then we're going to wrap up for today. I want to graph it. Let's just graph it. I want to graph a cosine similarity for various words, and then I just want to print them on the screen. So let's take a look over here really quick. See here. So we've got that option. We've got that option. What else do we got here? Is there like a let's see, heat? Is there a heat map? No. Core best heat map. Python lib terminal UI. Term graph. Okay. So we've got term graph. That is not really... Yeah, I guess it's right here. So we got term graph. I suppose we could... Yeah, let's do that. Let's do term graph. Okay. Yes. So I'm going to install term. So today we're doing Pytorch. We're doing Pytorch today. All right, and we're going to wrap up here. Let me paste this in really quick. All right, see, look at that. Isn't that great? Ooh, look at that right there. The shading. Oh, it's so good. All right. So let me highlight these guys here and then comment them out. There we go. So we will build a heat map using it proper. We're going to do it proper, you guys. We're going to do it proper. Just like that. Okay. Let me contribute this. Git status, git add model. And I'll add encapsulation and the model weights. Git status. Git commit. All right, we're wrapping up, you guys. Thank you so much for hanging out with me today. Commit AM. Prep for heat map on Monday. There we go. Good to go. Thank you so much for joining. We're pushed. There we go. Well, at least we did one thing. We got